The US military is making the most of its operations in Iran, not only eliminating Iranian missile stockpiles, launchers, and defense industry infrastructure, but also testing out new, never-before-seen weapons against its enemy. 3 new weapons, in particular, have been used to devastating effect against Iranian targets, perfectly demonstrating the United States' unrivaled strength on the global stage, an unwavering commitment to innovate, expand, and evolve its arsenal. So, here's a closer look at all 3 of those weapons, including their technical specifications, capacities, and how each of them have been used in Iran so far. The first, and arguably most exciting of the 3, is the Precision Strike Missile, or PrSM for short. The story of this missile goes back to 2016, when several big defense firms, Lockheed Martin, Boeing, and Raytheon, announced their plans to bid on a new US Army project intended to replace the MGM-140 Army Tactical Missile System, more commonly known as ATACMS. ATACMS missiles have been in service since 1991, proving their worth in numerous conflicts over the years, including Operation Desert Storm and Operation Iraqi Freedom. More recently, they've been seen in the Russia-Ukraine war, used by Ukrainian forces in numerous significant strikes against high-value enemy targets, such as Russian air defense systems and ammunition storage facilities. But even the best, most effective weapons eventually need to be replaced, and the US Army is always looking for ways to level up its offensive capabilities. It wanted missiles that could take that same destructive power seen in the ATACMS even further, with greater range and superior speeds. And so, work began on the PrSM, with Boeing and Raytheon eventually bowing out of the race, leaving Lockheed Martin as this missile's sole designer and developer. Originally, Lockheed Martin intended for this missile to have a maximum range of around 310 miles, or 500 kilometers. This was far beyond the 190-mile, 300-kilometer range of the ATACMS, but also remained within the strict limits dictated by the Intermediate Range Nuclear Forces Treaty, INF Treaty, which the US and Soviet Union co-signed back in 1987. Then, in 2019, the US withdrew from the INFT, paving the way for the PrSM to go even further than planned. 310 miles was no longer the peak, it was the baseline, with the Army announcing plans to extend the missile's range up to and beyond the 400-mile mark, potentially even pushing past 600 miles with future variants. The best part is that it doesn't need brand new launchers to cover those kinds of distances. It can be fired from the same pre-existing M142 high-mobility artillery rocket system HIMARS units that are already used to launch ATACMS, using advanced propulsion technology to fly faster and further than its predecessor. Even better, the PrSM is designed to be even thinner and sleeker than the ATACMS, meaning that 2 missiles can fit into each pod instead of just 1. So, not only does the PrSM fly about twice as far as the ATACMS, but also doubles the capacity of HIMARS launchers too. This allows the Army to retain the mobility of the HIMARS while dramatically increasing the density of firepower of each system. In short, it's an enormous upgrade, and this is just the start. The Army has plans to push the PrSM beyond its current operational limits in the years to come, with several increments already in development. Increment 1 is already in service with the US Army and Australian Army, and this is the version with a fixed treaty-bound range of 310 miles. Increment 2, also known as the Land-Based Anti-Ship Missile, LBASM, takes things further. Fitted with multi-mode seeker, it has the power to traverse denied areas with more ease than the original missile. It also travels further, with an estimated maximum range of up to 620 miles or 1,000 kilometers. In addition, as its name implies, the missile will have the power to strike ships, while its multi-mode seeker will allow it to engage moving targets, unlike the Increment 1. Increment 3 will expand the array of armaments the PrSM can carry, most likely introducing additional explosive munitions as well as submunition capabilities and opening up new opportunities for offensive operations. It's believed that this new and improved PrSM will, for example, have the extra firepower necessary to wipe out fortified enemy structures. Increment 4 will double the PrSM's baseline range, building on the foundations established in the previous increment, while improving the missile's propulsion and aerodynamics to reach the 620-mile or 1,000-kilometer mark. Finally, the last known increment in development at this time is Increment 5, which should allow the PrISM to be fired from an autonomous vehicle. As these increments are completed and integrated, the PrISM will fly further and faster, while also becoming more flexible to fit a wider array of emissions and uses. But it's already one of the most impressive new additions to the American arsenal, as Iranian forces have found out during Operation Epic Fury. There, the PrISM has made its official combat debut, as confirmed on the official X account of US Central Command, which wrote, "In a historic first, long-range precision strike missiles, PrISMs, were used in combat during Operation Epic Fury, providing an unrivaled deep strike capability." Admiral Brad Cooper, head of US Central Command, also confirmed that the US Army had launched its precision strike missile at Iranian targets, stating, "I just couldn't be prouder of our men and women in uniform leveraging innovation to create dilemmas for the enemy." Patricia Basilisk, an associate director at the Center for Strategic and International Studies Missile Defense Project, underlined the importance of this moment, telling Business Insider that the PrISM's debut signals the beginning of a new chapter of Army strike capability with significantly greater reach and accuracy. She's not wrong. While we don't have specific details about which exact Iranian targets the PrISM has been used against, there's no doubting the tactical advantage this missile provides to American forces. Since it can travel almost twice as far as an ATACMS missile, the PrISM can strike a far greater range of targets. That gives Iran more axes of attack to worry about, more important locations and assets to defend, with America able to pick from an array of potential launch points in Iraq and across the Gulf states. What's more, as a ballistic missile, the PrISM is capable of flying at very high speeds, especially during the final or terminal phase of its flight, as they hone in on their targets. This makes them perfect to use against time-sensitive targets like Iranian air defense systems and missile launchers. While we can't know for sure, it's likely that the US Army relied on these missiles in the opening salvos of the operation in order to deal massive damage to Iran's air defense capabilities in a short span of time, taking out missile platforms and radar sites to provide a clear, unobstructed path for additional follow-on attacks, while also clearing the way for aircraft to more safely enter Iranian airspace. And this isn't just about Iran. Deploying PrISMs in real combat conditions is a way for America to send a signal to other potential opponents around the world, including the likes of China and Russia, who will no doubt be keeping close tabs on the conflict as it unfolds. There's no doubt that these missiles could be used in future conflicts with either of those nations, and would give the US a serious advantage in a clash with China in particular. In fact, these missiles were designed with a hypothetical conflict in the Indo-Pacific in mind. There, due to the layout and geography of the region, land-based missile launch points are limited, and conventional missiles like ATACMS wouldn't have the necessary range to strike certain regions and targets. With their extended range and other superior capabilities, PrISM missiles would pose a much greater problem for Chinese forces to contend with, while giving America and its allies far stronger maritime denial capabilities. In short, the PrISM's debut has been a smashing success in more than one way. It validates the years of development and large investments that have been poured into this project, bringing the Army's high-end strike capacities to whole new levels. And it's just one of 3 new weapons we've seen being used in Iran so far. But before we take a closer look at the other 2, if this is the kind of insight you want more of, make sure you're subscribed to The Military Show. We break it down like this every week. Now, on paper, America versus Iran is a highly uneven contest. The US is the world's leading military superpower, spending more on its military than dozens of other countries combined. It has the best trained soldiers, the most advanced equipment, and an unparalleled pedigree of proven strategic success. But Iran did have one big advantage: drones. Recent years have seen drone warfare become increasingly important, with Russia buying up and producing large numbers of Iranian Shahed drones, which it has deployed to devastating effect against numerous targets across Ukraine. Iran has been producing these Shaheds for years and working on drone technology for several decades, enjoying a significant head start over other countries when it comes to drone production and deployment tactics. So, when Operation Epic Fury began, some analysts expressed concern that US forces may not be ready to deal with the Iranian drone threat. But America had an ace up its sleeve, an ace named Lucas, otherwise known as the Low-Cost Uncrewed Combat Attack System. Designed for the United States Armed Forces by US defense contractor Spectre Works, Lucas is a one-way attack drone that's actually based on Shahed technology. At some stage in the 2020s, according to US officials, a Shahed drone was captured and studied by Spectre Works engineers. They then set about reverse engineering the drone, copying parts of the Shahed's design in order to develop a similar sort of model for American forces, effectively turning Iran's technology against it. Progress was swift. Mere months after the program was officially unveiled in July 2025, Lucas drones were already rolling out to US forces stationed in the Middle East. In December 2025, the first Lucas drone was launched at sea in the Persian Gulf. Then, on February 28, the opening day of Operation Epic Fury, Lucas saw combat for the very first time. A press release from CENTCOM details the power and potential of these systems. Lucas drones deployed by CENTCOM have an extensive range and are designed to operate autonomously. They can be launched with different mechanisms to include catapults, rocket-assisted takeoff, and mobile ground and vehicle systems. Speaking to CNN, a US defense official also acknowledged that the American military had a history of focusing on larger and more expensive military systems, which could have put our forces at a disadvantage against cheaper, simpler systems like the kamikaze Shahed drones employed by Iran. With Lucas, however, the US is, in the official's words, flipping the script against its opponent. Using those same cheap drones, each unit is said to cost around $35,000, a fraction of the cost of missiles and other munitions, to give Iran a taste of its own medicine. Official sources have declined to state exactly how many of these drones are currently available to America's forces, but they have said that many are available and more are on the way. Given how cheap and easy they are to make, and how much money the US has to spend on its military, it's easy to imagine a near-endless supply of these one-way attack drones rolling off production lines and being dispatched directly to American crews across the Middle East. While we don't know too much about their exact technical specifications or capacities, experts have analyzed images of the Lucas drones in an attempt to learn more about them. They soon spotted that these drones are equipped with nose-mounted gimbaled camera systems, as well as satellite connectivity modules. This should, in theory, make them notably superior to the Iranian Shaheds. Satellite connectivity would allow Lucas operators to retask their drones mid-flight, updating their target data or destination coordinates, for example, and allowing them to respond to changes in battlefield conditions on the fly. In the future, this technology could also support AI-powered swarm tactics, involving the use of emerging AI technologies to conduct large-scale coordinated drone attacks. Even without that type of technology available right now, if US forces have enough of these drones, they could launch them in groups and clusters in order to saturate Iran's radar systems and bypass its defenses, or even create safe pathways for much more destructive weapons, like US and Israeli long-range missiles, to travel through. This in turn could allow America and its allies to strike the most hardened and valuable targets in Iran, like strategic bunkers and nuclear bases, with relative ease. The remarkable irony of all of this is that the US probably wouldn't even have low-cost drones like Lucas if not for Iran. The Shahed was one of Tehran's proudest accomplishments, but the US took that technology, fine-tuned it, and unleashed it against its original creator. There's no telling how much damage Lucas drones have already done in Iran and could continue to cause, but it's an exceptionally important addition to the Army's arsenal at a time when drone warfare is of growing importance all around the world. The third and final new weapon unleashed on Iran is a fresh twist on a familiar munition, the Tomahawk missile. The BGM-109 Tomahawk Land Attack Missile, or TLAM, is one of the most powerful missiles on the planet. Famed for its extraordinary range, this all-weather, jet-powered subsonic cruise missile can cover distances up to and over 1,000 miles. It's not only used by the United States Navy, but also by the Royal Australian Navy, the Royal Netherlands Navy, and the British Royal Navy. However, these navies deployed the missile from different platforms. The US and Australian navies operate it mainly from surface warships. The Netherlands plans to field it from surface frigates, while the British Royal Navy launches it exclusively from submarines. Developed decades ago at the Applied Physics Laboratory of Johns Hopkins University, the Tomahawk first entered service in 1983, and we've seen several variations on the original design introduced over the years, including the RGM-UGM-109B anti-ship variant with active radar homing to the RGM-UGM-109E tactical Tomahawk model. But even though these variants often had different technical specifications and capacities, they always had one thing in common: their color. No matter the exact model number or variant, Tomahawks have historically been painted in a sort of hazy grey tone, which also tends to feature on many more of the US Navy's weapon systems and other assets. Then, Operation Epic Fury started, and the Navy shared the first few pictures from the battlefield. Those images revealed something the world had never seen before: a Tomahawk missile painted with a glossy black finish, a stark contrast to the usual grey tones. According to data and reports released by the US military, this intriguing new variant was used for strikes aimed at neutralizing Iranian air defenses and maritime targets, possibly including naval bases near the Strait of Hormuz. Open-source intelligence analysts and media agencies soon confirmed that the Black Tomahawk had been used during the initial salvos of the operation, and experts soon started sharing their theories for why the missile had been painted in such a different and distinctive way. They realized that the same black coating had also been seen on another missile in the US Navy's arsenal, the AGM-158C Long-Range Anti-Ship Missile, LRASM to be precise. It's believed that this glossy black finish isn't just for show. It acts as a low observable coating, making use of radar-absorbent materials and infrared suppressive properties to make the missile more difficult to detect while in flight. So, while it may at first glance appear little more than a minor aesthetic addition, the black paint of these new Tomahawk missiles is actually quite a serious upgrade. It most likely enhances the missile's performance against sea-skimming profiles, improving their survivability and increasing their chances of evading interception and successfully striking their targets. With the traditional grey paint, Iranian radars and air defense systems would still find it difficult to intercept Tomahawks, but would be able to spot them sooner and with greater accuracy, giving them more time to orchestrate and execute an appropriate response. The black paint effectively muddies the water, making it far harder for Iran's radars to see the missile, especially while it's traveling over oceans and seas. The deployment of the Black Tomahawk marks a clear strategic shift by US forces towards stealthier cruise missile capabilities, which should in turn provide superior penetration abilities against fortified targets deep inland. It's possible, for example, that these missiles played a critical role early in the operation in terms of dismantling and destroying Iranian radar networks, facilitating follow-up attacks by drones and penetrating aircraft. Iran, meanwhile, most likely had no idea what hit it. Despite investing heavily in radars and air defense systems, it couldn't have possibly prepared for a super stealthy Tomahawk attack, with these mighty long-range missiles soaring by its defenses before they even had time to react. Now, thinking more long-term, missiles like these should improve America's prospects when it comes to deterrence against maritime threats in the Persian Gulf and beyond. The Black Tomahawk is a formidable threat for any enemy to encounter, and a clear demonstration of the US's ability to consistently level up its armament in the most innovative and impactful ways. Like the Prism, it also shows how the US is so often able to upgrade its missiles and munitions to maintain operational superiority without needing to waste huge amounts of time, money, and resources, making entirely new launch platforms too. America's enemies, like China and Russia, are most likely already working on ways to counteract these missiles, as well as the other new weapons unleashed in Operation Epic Fury so far. But the US is always one step ahead, never settling for second best, and always seeking to strengthen its arsenal and maintain its uncontested status as the greatest military force the world has ever known. Now, you can learn more about how Operation Epic Fury unfolded in this detailed breakdown, which explores how US forces shattered Iran's defenses in the opening hours of the conflict. Alternatively, check out this video for a detailed look at how America's world-leading bomber flight decimated Iranian missile sites and command centers with unmatched efficiency. And for more insightful analysis, strategic deep dives, and breaking military news, make sure to subscribe to the channel.